Thanks everyone for coming. Welcome to our talk, Text in Flutter, Building a Fancy Chat Bubble. My name is Gary Chen, and I'm a software engineer on the Flutter team at Google.
And my name is Qian. I'm also a software engineer on the Flutter team.
So hopefully, a lot of you already know what Flutter is. But if you don't, Flutter is an open source cross-platform framework for developing applications. Flutter aims to be beautiful, productive, fast, and open. Let's take a look at each of these really quick. Beautiful. Flutter draws elegant, pixel-perfect UIs. Fast. Flutter compiles to native machine code. Productive. Flutter's declarative code style and sub-second hot reload allows massive reduction in development time. And finally, open. Flutter is completely and proudly open source. We welcome you to explore what Flutter can do in the Flutter Gallery app, which can be found in the Flutter Gallery examples section of the code base.
Hey, Gary, Flutter looks great. I had a genius idea of making chat app. This is what I have now. How does it look?
That looks really bad. Well, since you're using Flutter, why don't you use Flutter to turn it into something like this?
Wow, that looks great. Let's do this.
OK, so you just have a plain text right now. You should start with drawing the actual bubble.
Sure. So container is one of the many widgets in the Flutter framework. It combines common painting, positioning, and resizing. Let's draw the bubble with a container. In this section, we're going to start with giving our container a color. And then we're going to add some padding. And then we're going to replace the color with a nice-looking gradient. And then we're going to use border radius to draw the bubble shape. And finally, we're going to add some shadow. All right, let's go to the demo. All right, so let's take a look at the code right now. Now we have a class bubble that extends a status widget. And then in the build method, we're returning one container. And on the right side is the code running. All right, so let's go ahead and add some color to our container. Which we're going to add color. All right, so if we save the code now, the Flutter is going to hard reload for us, which means that you don't have to restart the app to see the change. So let's do that. Now we save the code and hard reload it, and then you see the change appeared on the right side. All right, so now let's go ahead and add some padding to our container. We're going to add padding, and then we're going to create an edge insets object, and then give it 15 padding. If you save the code now, it's going to hard reload again, and now you see the padding right away on the right side. All right, so instead of color, let's replace it with a gradient. So to add a gradient, we're going to use a decoration. And then we're going to create a box decoration object. And here, we're going to create a linear gradient object. And then we're going to give it some colors. And we want the gradient from top to bottom, so let's give it alignment top. And alignment bottom. All right, so if we save the code now, we should see the gradient appeared on the right side. All right, let's come back to the slides a bit. So we've used the box decoration to add some nice-looking gradient. But there's a lot more can be done with box decoration, such as shape, border radius, and shadow. Let's complete the bubble by adding a border radius and shadow. All right, coming back to the code. So here, inside the box decoration, we're going to add a border radius. And we're going to create a border radius object. And we're going to give it some radius right here. And we're going to add the radius for the top left, top right, and bottom left corner. And then we're going to leave the bottom right corner sharp. So we're going to remove that. And if we save code now, it will hard reload again. And now we have the bubble shape. All right, finally, let's go ahead and add the shadow. Here we're going to add the box shadow object. And give it some blur radius. add some offsets, and then some colors. All right, save code to hot reload. And now we complete the bubble with it's floating. All right, come back to the slides. So here's a summary of what we've written to draw the bubble. We only wrote 21 lines. So we've used some out-of-the-box widgets in the Flutter framework. But there's no limit to what you can draw with Flutter. Let's take a look at the diagram on the right. You'll see that the Flutter framework is written in Dart, including the material layer, the Cupertino layer, and more. And the Flutter engine is written in C++. The highlighted Dart UI library, which builds the interface between the framework and the engine. It exposes Qian, our C++ drawing library, which then can be used to build fully custom UI. So when writing a Flutter app, you're not limited to only use pre-built widgets in the framework. Now that we have the bubble, we can style the text.
Yeah, the bubble looks great. But let's see what we can do with the text. So we'll start off by replacing the plain text widget with a rich text widget. This will allow us to add a lot more things in, such as this text style, where we can adjust things like the font size. We can also adjust things also in the text style, such as decorations, to draw this wavy red underline. Then we'll see how text spans can override text styles defined in a tree of text spans by defining smaller text. And finally, we'll look at a feature called strut to maintain consistent line heights across paragraphs. All right, let's go back to the code. So here we are in the code. We're going to start off by replacing this text widget with a text.rich widget by using the text.rich constructor. Now, the text.rich constructor no longer takes text. Instead, it will take a text span. And we'll go ahead and define a build text span helper method, which we can define down here. And this one will just return a text span. OK, so this will just return a text span. Now, a text span is actually a node in a tree of additional text spans. So you can define this by creating a text span and then having the children property have a list of additional text spans. We'll go ahead and do that, and we'll set the text for this child text span as the original text we had. So if we hot reload this now, you'll see that nothing has changed. And that's OK, because we haven't changed anything. But now let's go ahead and define a style in the parent text span. And we'll go ahead and set the font size to font size. And here, we can take this variable and define it up here. So let's come up here. Font size, and let's set it to font size 20. And we hot reload this. And you'll see that even though this text style wasn't defined on the style of this text span with the text in it, the child text span was able to inherit the text style of the parent. Great. So let's go back to the slides really quick. And these are all the properties available in text style. In particular, let's take a look at the decoration properties to draw a wavy red underline under a misspelled word. Let's go back to the demo. OK, so we'll go ahead and duplicate this. And let's type a obviously misspelled word. And we're going to go ahead and give this a text decoration using the text style properties. OK, so we'll go ahead and give this a decoration. And we'll use the text decoration. And let's set it to underline to give it an underline. So let's set a decoration style. And let's give it the wavy style. And let's set the decoration color to colors.red. And let's go ahead and hot reload this. OK, so you see that now we have this word misspelled. And it now has this wavy red underline underneath it. You can also define things like font weight. And if you just set it to bold like that, boom, it becomes bold. OK, so we've seen that we can easily define different properties in text styles. Now, what happens if you take a text style and override the properties in the parent text style? So let's go ahead and add some new lines here to see the effects. And let's define a style here that will override the font size. And we'll set this font size to be half the font size as before. And let's hot reload that. OK, so you see that now we have this line that is half the size of the other lines. Because we redefined the font size property here in the child text span, it overrides the font size property in the parent text span. OK, but you notice that the line height of this text is actually small now. Let's go back to the slides real quick. And luckily, Flutter actually has a feature called strut. Strut defines the minimum line heights across the entire paragraph. This can be used to define consistent line heights across different fonts and font sizes. Let's go back to the slides. I mean, the demo. OK, let's go ahead and add a strut style to this. The strut style belongs in the rich text here. And we can just simply add a strut style. And let's define the font size in the strut style. And let's set it to the font size we defined. OK, so if we hot reload this now, you'll see that now this small line has the consistent line height across the entire paragraph. It now takes the same height as the other lines. OK, let's go back to the slides. Great. So this is all of the text we added. This is all the code we added to get this text. We added another 21 lines of text. But now that the text is kind of small, I'm having a hard time reading it. Is there something we can do about that?
Sure. We can add a pinch gesture so our users can scale the text if they want to. So we'll start with changing the bubble to a stateful widget. And then we'll go ahead and add a gesture detector widget. And finally, we're going to add the onscale start and the onscale update callbacks to accomplish the scaling. So remember our bubble was a stateless widget? We're going to change it to a stateful widget. What's the difference? Basically, a stateless widget never changes, and the stateful widget can update itself. A stateful widget requires to be paired with a state object to build the widget. And finally, you always have to call sysstate after changing the state. Now, let's take a look at this in action. All right, let's go back to the demo. All right, so now we have the code here. First, we're going to change our bubble from the stateless widget right here to a stateful widget. Let's use some help from the IDE too. If we click here on the bubble, and then we click on the light bulb shows right here, and then we can select the Convert to Stateful Widget drop-down menu option. If we do that, boom, the IDE did magic for us. All right, so after you change the widget from a stateless widget to a stateful widget, you always have to perform a hot restart if you want to keep the app running. So let's just do that right now. We can do that by clicking on the green button right here on top. All right, so I'm going to click on that. And the app is hot restarted and then still running. So now let's go ahead and prepare some variables to accomplish the scaling. Because we're going to scale the font size, it cannot be final anymore. So let's go ahead and remove that. And then we still need a constant variable of font size. So let's create one more final. And let's call it base font size, so we know which font size to be scaled from. And then we want to record the font scale all the time. So let's create another variable called font scale and default to 1. And finally, we want to record the current font scale in the beginning of each gesture, so we know what is the base font scale we can scale from. So let's create another one called base font scale. All right. So now let's go ahead and add a gesture detector to our container. To add a new widget, we can also use some help from the IDE. If we click on the container and then click on the light bulb right here, we'll see the drop-down menu, and then we just need to select the wrap with a new widget option here. If we do that, now it created a new widget for us wrapped around the container. So let's format the code a little bit. All right, so now we just need to change the widget here to a gesture detector. And then let's go ahead and add 2 callbacks that I just mentioned. OnScale start. Actually, scale start. Oh. And OnScale update. All right, so OnScale start. We want to record the current font scale in the beginning of the gesture. So let's go ahead and add calculate the font, the base font scale, which is equal to the current font scale. All right, so OnScale update. Here we're going to calculate the new font scale based on the base font scale that we just recorded. So base font scale is going to equal to the base font scale times the scale factor of the gesture. So that'll be this. And we're going to clamp it so it doesn't get too small or too big. All right, so finally, let's calculate the font size based on the font scale that we just calculated. It's going to be font scale times the base font size. And finally, remember, we have to call the setState method after changing the state. And then we're going to wrap everything around inside the setState method. And let's format the code again. All right, so now let's save the code, hot reload, and then see if it works. So now I'm going to pinch on the bubble and see if it works. All right, so now the texts are scaling, and then see they're flowing inside the bubble. Cool. All right, come back to the slides. We only took 15 lines to accomplish the gesture. So remember that Gary used a text span to concatenate multiple text spans? A text span can also attach widgets as one of its children using widget span. We're now going to add some widget span to our text. First, we will attach some GIF animations to the text span. And then we're going to explore what other widgets can be added to the text span. All right, let's start a demo. All right, so now coming down here to the build text span method that Gary created for us, we want to add a widget span right here. And we're going to give it an image widget, and then we'll give it some images we prepared before the talk for our logo. And we want to set the same size as the font so it can scale with the font. All right. So just for the sake of fun, let's add a lot of them. All right, I'm going to format the code a little bit. All right, I'm going to save the code, hot reload again. Now we should see the animated GIF are attached to the text. And then they're also scaling with the text and flowing inside the bubble. Cool. So there's actually no limit to what widget you can add to a text span. Let's try something else. How about a full app? Remember Gary showed us the Flutter Gallery app in the beginning of the talk? Let's try to add that into our text span. All right, let's come down here. And here we're going to add a widget span again. And instead, this time, we're going to use a clip rec widget combined with a sized box widget, and give it some fixed size so we know our app is fixed size. We don't want to scale the app. And finally, we're going to add the gallery app. All right, so let's see how it looks. Save the code, hot reload. Now we have the gallery app showing inside the bubble, which is attached to the text. And it's actually fully functional. We can just directly use it and then read some recipes right here. Check out some animations. Everything inside the bubble. All right, cool. All right, let's go back to the slides. Guess what? We only added 10 lines.
So we've been tracking the number of lines. And after adding it all up, we did this all with Flutter in just 67 lines of code. So let's take a look at one of the libraries that makes this all possible, LibText. So what is LibText? Well, to put it simply, LibText takes the C++ string we have here, hello world, and changes it into this final rendered text. It can also add things like all sorts of crazy decorations, fonts, and colors. If you take a look at the layers diagram again, you see that LibText lives in the engine layer, highlighted in blue, and LibText is circled in red right there. Right above it is Dart UI. So Dart UI exposes LibText's C++ API for the framework to use. LibText is similar to Blink, Cortex, and Tech, if you're familiar with those frameworks. So why did we write LibText? Well, if you take a look at Flutter's history, Flutter, way back in the day, used to use Blink as its text rendering libraries. Blink is the rendering engine behind Chromium and the Chrome web browser. So because it was we used Blink, which is the rendering engine for the Chrome web browser, we had a lot of legacy and compatibility features from Blink. This meant that Flutter had to keep all of those features, even if we didn't want them. In addition, Blink is partially LGPL licensed, which isn't as open as we wanted Flutter to be. And finally, we're unable to customize Blink, because you can't just change the entire web because Flutter wants to change something. So let's take a look at the implementation. LibText has some core dependencies of Harfbuzz, Skia, and Minikin, where Harfbuzz does the low-level layout, Skia handles the font rendering and loading, and Minikin ties it together. Its API is primarily based off of the Blink-style API. And finally, LibText has deviations from the web. Let's take a look at the API. The two primary classes we deal with are Paragraph Builder and Paragraph. Paragraph Builder takes in Unicode strings and text styles, and then compiles that into a paragraph object. And the paragraph, you can do layout, which will lay out the text, and finally, call the paint method to paint it onto any SK canvas. So let's take a look at how LibText is used within Flutter. So here's a quick diagram of how the text widget works. If you look at the bottom here in the engine, you can see that LibText sits at the very bottom with the C++ implementations of Paragraph and Paragraph Builder. Right on top of that, mirroring the LibText C++ implementation is Dart UI's Paragraph and Paragraph Builder. This takes the C++ API and turns it into a Dart API, which then the framework can use. Starting from the top now, we have the plain text widget, which behind the scenes is actually a rich text widget in disguise. Underneath of that is the render paragraph render object, which handles taking that text and telling the text painter what to do. And the text painter then directly uses LibText's API to draw the text. So let's take a look at something like text field. Text field actually reuses most of the code. So because of Flutter's layering framework, we didn't change anything in the bottom section. We still use the text painter, which talks to Dart UI, which converts to LibText. Instead, all we have to change now is the top section, where the text field in the material layer is backed by an editable text, and underneath of that, instead of a render paragraph, is backed by a render editable. Great. So what benefits did we gain from implementing LibText ourselves? Well, the biggest one is we're no longer tied to the web. We don't have to use a web text layout library for Flutter. Because of this, we gained a lot of performance. Because we don't have all these legacy features of Flutter, of Blink, we stripped it all out, and now we're left with a much faster framework, a much more lightweight framework. Additionally, because we control LibText fully, it's highly customizable. We're able to add features rapidly. And finally, LibText is fully open source. You can take a look at the canonical source code of LibText at the link below.
Today, we've seen how we can build a chat bubble with some advanced text features in Flutter. We've also dove into the LibText library, which makes all this possible. If you want to learn more about Flutter, please check out flutter.dev or flutter.cn. That's all for us. Thank you for coming.
And of course, let's finish it off with the best way to finish off any talk, with a stage selfie.
Thank you.
Thanks, everyone.